In this video, we are going to have a quick look how the simulate interface looks like. First, let's look at all the ribbon tabs. We have File, Home, Data and Rules, Insert, View, Visual Logic, Advanced, Help, and we are going into the details in other videos for relevant tabs. Next, let's look at all the quick access tools. The quick access menu is also accessible from any type that you are on. So it contains all the options you might want to use at any stage in building and analyzing your simulations. Right here we have the application buttons, the open recent file, save file, undo, redo, run simulation, reset simulations, or one step forward of the simulations, or we have the simulate assistant. This assistant monitors your simulation building and the way you are using your simulation to provide advice to help you get it right. And very important, we have the building blocks right here, or we call simulation objects panel. This simulation panel contains all the tools that you need to draw your simulations. So here you can see simulation objects, including start point, queue, activity, endpoint, resource, etc. And next to the building blocks, we have the simulation window. The simulation window is where you draw your simulations. And you can see we have a clock here. It determines the working hours of your simulations. Last but not least, we have all the view tools. The view tools let you control how you see your simulation. From left to right, you have the overview windows. This overview window lets you pan around large simulation easily. You have presentation mode. This button helps you display your simulation in full screen mode without all of the toolbars. And you have the button 100% that help reset your simulation back to 100 zoom level. And right here, you have zoom adjustments to have you to zoom in and out the display of your simulations. A simulation is made up of objects in a structure. So here we call it a structure of simulations, and it includes several objects. The main simulation objects contained within simulate are the start point, right here, where the work enters the simulations, the queues, where the work waits to be processed, the activities, where the work has something done to it, the endpoint, where the work leaves the process, and we also need the resource. The resource could be any items, people, or parts that are needed to help process your work. And each icon here represents an object in your simulation. The structure is presented on the screen by a number of objects and connecting by the lines. And this is what we call the routing arrows. And when we run the simulations, we will see the work items that are flowing around the simulation like this one. And we can see the clock shows the simulation time as it runs. The clock will determine the working hours of our simulations. And very important right here, we have a concept called the result collection period. Right here, we can tell the simulation how long we want to run and collect the result. And in this case, that is 1 day. At the end of the simulation, we can see the result. So here in this video, we already covered several key concepts: start point, queues, activities, endpoint, resources, routing arrows, running simulation, clock, results, collection period, and results. There are several things to set up on the clock to ensure you get the most from your simulations. Before going any further, you need to decide which time units to work in: seconds, or minutes, or hours. You should also think about how long to run your simulation. For instance, do you want to look at your business process over a day, a week, a month, or a year? And to assess the clock properties, simply double-click on the clock on the main simulation window. The first thing, we need to decide this time format. You can choose between time and day, time only, percent, simple unit count. For the time and day, this is the default setting and will display the current time and the day of the week. For instance, right here is 9 a.m. on Monday. In the Properties tab, you can set up the running time. This is where you can set up the duration of a day for your simulated process. This requires the daily start time. Here is 9 a.m. The daily end time here is 17. The duration of the day is 8. And the days per week is 5. So let's change the daily start time from 9 to 8. You see the daily end time already changed from 17 to 16, given the duration of the day is 8. And if you click OK, you can see the clock change to the starting time of the day is 8. Simulate defaults to run for a 40 hours week from 9 a.m. to 5 p.m. from Monday to Friday. And you also can change the result collection period within this session. By default, your simulation will run for 1 week. If you want to run for a different amount of time, you only need to change the result collection period right here by day, by month, or years. The next thing you can set up is the type of time units. You can choose between seconds, minutes, hours, or days. Just a notice, all timing values in your simulation will follow the time unit you select right here. If you choose minutes, it means all values you need to enter in minutes for your simulation. Let's build a basic simulation now. We can start with the start point. Just click on the icon and drop the object somewhere on the screen. And we will click the queue icon and do the same. Then we should place an activity on the screen using the activity toolbar icon. And finally, create somewhere where our work item leaves the system with the endpoint object. As now we see the title for the activity, but we didn't see the title for the start point, the queue, and the endpoint. We can do something, let the system show us the titles. So we click on the start point, go to the graphics, and show the title. The same for the queue, show the title for the queue. And the same for the endpoint, we can show the title as well. All right. And you can see that the simulate has automatically linked all the objects together by the red arrows. And I think right now, we're already ready to run the simulation. We just click run simulations. So we will see all the work item, the red bones, moving between each simulation object that we have created. And to stop the simulation, we also can click the run button again. But in this case, it's already stopped automatically by the end of the result collection period, which is 1 day. And results are available for every object in our simulation. This means that every start point, every queue, every activities, and every endpoint will have their own set of results. So let's click on the queue result. So we see a new dialog. And in this dialog, we see the length of time the work item spent queuing, minimum, average, or maximum time. And we also can see the number of the work items already in the queue, which is 50. Now it's time you can try on your own, try selecting different objects. In the simulation explore, the results are available for each. In this video, we are going to discuss about another type of object for simulation, which is resource. We can use resources to constrain an activity so that something in your process cannot happen if the relevant resource is unavailable. Now, let's build a simulation for medical appointments, and we are going to use the basic simulation which we created in another previous video. You can check that video using the pop-up link or using the link in the video description. So first of all, to assign a resource, we need to have a resource first. You can click on the resource icon and place the resource in the simulation window. You can change the property of the resource, and the resource here is doctor. And we know that we will have 4 doctor for all medical appointments. So we type 4 here and click OK. And the activity in the simulations is the medical appointments. So let's call it an appointment. All right. And let's assign the doctor resources to the appointments. How to do that? We can double click on the appointments, click resources, add, choose doctor, which we just created, click OK, OK again, and OK. Now, the doctor resources are assigned to the appointment activity already. And there's a notice that you can assign several different types of resources to one single activity. And an individual resource can also be assigned to many different activities just in case. If you click on a resource or activity where it is assigned will be highlighted in red. The default setting is that when you assign a resource to an activity, the resource is required at the beginning of the activity and then released when the activity is complete. This is particularly useful in our case like doctors as a resource. Those doctors will usually be required during appointments and then released when the patient leaves the appointment. In this video, we are going to discuss how to change the resource requirement using the medical appointment simulation that we created in another video. You can check that video using the pop-up link or use the link in the video description. By default setting, when you assign a resource to an activity, the resource is required at the beginning of the activity and then released when the activity is complete. You can change this. Instead of being released when activity finished, the assigned resource is retained and stay with the work item until you say otherwise. We will explore these options with this new example. Right here we have 2 type resources, 7 nurses and 4 doctors. We know that a nurse will be needed both at the check-in activity and at the appointment activity, while a doctor is only needed at the appointment activity. We can set it up so that a nurse will stay with a patient during the process of checking in until the end of the appointment activity. First, we select the checking activity. We click on resources on the ribbon. We choose to add a nurse resource. Click OK here. And we need to check the property of the nurse resource. As you can see in this dialog, the 4 options on the bottom half of this dialog give you the option to change the default resource requirements. The current property of the nurse resource is normal. Require and release the resource here. We want to change this so that we do not release the nurse after the checking in activity. We need to select the second option, require here, but do not release the resource. This means that nurse will stay with the patient work item until we tell it otherwise. And then we should click OK. OK right here. We now need to set our example up so that we released the nurse after the appointment activity. We select the appointment activity, click on resources. We add nurse resource. And we need to change the default requirement for this resource using the detail button. The current property is normal. We should select the third option, only release the resource here. We already have a nurse resource with our work item from the river checking activity, so we don't need to require another one. That is the reason. All we need to do is to tell our model to let the nurse resource go after the appointment activity. And that's it. It's done. Now you can try to run your simulation. In this video, we will reconsider the medical appointment simulation example when doctor work in shifts. You can check the relevant video in the pop-up link, or you can use the link in the video description. So far, we have assumed that we always have the same number of doctors available regardless of the time of the day. In reality, this is likely to change, and different quantities of doctors may be available on different shifts. That's why in this video, we are going to create the shifts for the doctors. And shifts can be created by double-clicking on the resource object, and it is doctor in this case. We choose shift dependent, and next click on the shift work patterns. Let's create a new shift. Let's call it a day shift. And the doctor are supposed to work from 9 a.m. until, let's say, 1 p.m. And they are not working every day, but just a few days in a week. Let's say from Monday to Saturday. Okay. Now, the shift already created. We can click on the doctor resource object again and take on the shift dependence, and we can clarify how many doctors are available for the shift. Let's say maximum number of 4 doctors available for the shift. Click OK. And now let's run the model and see what happens. All right. When the doctor work in shifts, and in a day they can serve around 22 patients, we can check this result when the doctors work normally every day and 8 hours a day. We can change the shift dependent property for the doctor resource. We can click on this object. Instead of choosing shift dependence, let's go back to the original setting with 4 doctor or full time, right? And now it's time we can run the model again. So see, when a doctor works full time, they can serve up to 40 patients in a day, which is a larger number than the number of patients when the doctor works in shift. It is a note that some resources in the real life may have the same number available regardless of what time of day it is. For instance, the hospital beds or the machinery in a factory. And we do not have to make the resource shift dependent if the number available does not vary. In this video, we are discussing how to use the routing out feature with label as a discipline. We will use the simulation structure on the screen right now to assign a value to each work item at the queue to send the blue work item to the blue queue and green work item to the green queue. Given that we already have a created label called label color, so please check the relevant video in the pop-up link right now or use the link in the description. We can check the label created. Go to data and rules and labels. Right here, we already have a label called label color with 1 value for blue and 2 value for green. We will attach label color in the start point in this example. And to do this, we just click on Add Object button in the central label editor. And we choose Start Point. When this is done, we need to choose what action we would like our label to take. This can be done by clicking at Action right here. We can choose one of the action options on the right-hand side of this dialog so that we can tell our simulation what to do with the label. And in this example, we are going to say that each work item is equally likely to be a blue or green We can set up our simulation to reflect this so that the label value is equally likely to be 1 or 2. And to do that, we choose set to. And in the new dialog, we choose the distribution called the routed uniform. Why? Mathematical equivalent of the likelihood 1 or 2 is a routed uniform distribution with lower bound 1 and upper bound of 2. This means that any value is equally likely to occur between the lower and upper bound, and only whole numbers can occur. We click OK and OK. Now we have attached our label and set its value. Next, we select activity and then we choose rooting out on a ribbon. We are going to root out using the label discipline because it is the label value which determines where the work item should go. When we choose label as a rooting out discipline, the dialog shows a list of all labels in our simulation. Whichever queue we have first in the list will take label value 1 by default, and whichever queue we have second in the list order will take label value 2, and so on. If these are wrong way around, the pointer arrow can be used to change the ordering. Then we can click OK now. So we are ready to test our simulation. We can test whether the label values are being correctly assigned to our work items. So let's check the blue first. Click on the blue queue and go to property and check the current contents. So we are expected each work item will have value of 1. So it's correct. And do the same for Rin. We can check its current contents. So we are supposed to expect all the work item have value of 2. That's amazing. We use labels to attach a value or attribute to a work item. Put it differently, we are creating a new variable if we use labels. At the moment, all the work items traveling through our simulation are the same. For instance, they have no distinguishing attributes. We want to distinguish between different types of work item. For example, by marking each one as either blue or green card type. Okay, we are going to use this structure in order to create a simple example using labels. We will assign a value to each work item, telling us whether it is blue or green. We can then use this information to send the blue work item to the blue queue and the green work item to the green queue. First of all, we need to create a new label. Clicking on the label button on the data and rules tab will take us to the central label editor. This is a list of all the labels in our simulation, and this will be blank if we have not previously created any labels. For instance, like this case, we will select Add Label to create a new label. First, we need to enter a name for the label, and let's call the label here is label color. Please note that only one label is needed for distinguishing the work items based on the color, rather than one label for blue and one label for green. We now need to choose whether to create a number or text type label. The number type label are more versatile because they can be used for mathematical functions later on. So it's generally a good idea to pick a number style label as a default. At this point, we can also add a memo to our label. A memo won't change our label in any way. It is used just to remind us of what the different label values represent. We are going to give our label color to different value depending on whether a word item is blue or green. Let's have one for blue and two for green car. Adding something like this to our memo box will remind us of what the value represents later on. At this point, we have created our label called label color, but we didn't attach it anywhere in our simulation. And the label can be attached in start point, queue, activities, etc. As a general rule, we should attach a label as soon as we know the relevant information. In this car example, we could attach the label in either the start or the activity, and the outcome would be the same. In this video, I will show you how to assign a label to an object and how to assign a value to that label. All right, on the screen right now, we have a very basic simulation model. And if you want to figure out how to build this basic simulation model, please check the pop-up link above. Or you can check the related videos in the description. All right, so right here we have this start point, the queued activity, and the endpoint. So we can show the title for the endpoint. Good. So imagine the system is a small organization that we serve our customer, and this start point is where customer arrive. So when customer arrive, we can collect several information like the order of the customer arrive at our company premises, and as well as what time did they come, right? So let's create a variable or a label. And again, you can see the relevant pop-up link to show how to create a label. Let's do it now. So we can go to data and roost, go to label, and we will see the label editor window. So right here, let's add a new label. Let's call it customer ID, right? And let's choose the default type of this label is number. Click OK. All right, we can add this label customer ID to an object. In particular, the object we want to add to is the start point. All right, we can add the object, the start point. Good. All right, now we need to assign a value to this label. And to do that, we can click on add action. So basically, each customer need to have a unique ID. So basically, we just choose unique, click OK. Right. Click OK. We can try to run the simulation. All right, so let's check the current content at this queue here. All right, go to check the current content, and we see we have a few customer are in the queue, the waiting area now. For instance, we know this is the customer has an ID 43. Good. Now let's create another label. The time the customer did arrive. Okay, again, go to data and roost, go to label and add a new label. And let's call it the time in when customer in the company or organization. All right, and let's choose the format of this label is number as well. All right, and we will do the same. We will add the time in label here to the object start point. All right, and the last step, just add a value, assign a value to this label. We can choose the timestamp data for this label time in, right? And click OK. Click OK again. Now we're happy to run the simulation again. All right, let's look at the current content in this queue again. Now we not only know the order or the number of the customer is waiting, customer 43, but we also know that this customer arrived at 470 minutes of the day. Opposite to batching, we use the collect feature to assemble several items together in an activity and create one individual item as an output. And here in this example, we are building a simulation to collect one car body and four wheels in order to output one complete car. We have two queues with 100 work items each. The next step is to configure the car assembly activity, so it knows how many work items to collect from each queue to assemble one complete car. To do that, we select the car assembly and go to routing in from the ribbon. Next, we choose the collect discipline from the list on the left-hand side of this dialog. And now we are ready to tell the simulation how many work items to collect from each queue to output one work item. And configure this by selecting each queue and typing the required number in the input box next to collect. We are requiring one car body and four wheel to produce each complete car. We will notice the list will update to show the required amount of work items from each queue. Now we are ready to run the simulation. After running the simulation, it should look like this. We have created 25 cards and one still in the progress, stuck in the car assembly activity because we have run out of the wheels. And to avoid moving work items into the activity before all the required parts are available, we can adjust some properties of the collecting feature. Click on this one. We can choose routing in, and for the car body, let's choose do not collect until all available. Okay. Now let's run the simulation one more time. See, we still make 25 complete cards, but at this time there is no car body kept in the car assembly activity. Batching in simulate is a term given to situation where you will split up a work item into more than one work item. For example, if a piece of materials arrives at a factory, it is one work item. But at an activity, you may cut this up into, let's say, two separate pieces. You now have two work items rather than one, and it is important to represent this in your simulation. So let's use a simple simulation in this example to demonstrate how we separate things. Before the simulation is run, there will be 100 work items. And activity 1 will batch or separate each work item into two. In this model, we will set a startup value of 100 work item in the first queue. You can do this by selecting the queue and clicking Startup in the Properties tab. Go to Startup and we can set up, we have 100 work item at the first queue. All right, next, set the batch size of the activity 1. The default setting is that one work item in equal to one work item out. So we just select these activities. And then we go to routing out. Click on the batching button. And the new dialog will ask you to enter the batch size, leaving this activity object. This is the number of work item which will leave the activity for each one that enters. And in our example, we want two work items to leave for every one work item that enters. So just specify the batch size will be 2. All right. Now we can run for the simulations. As you can see, almost like 50% of the item has been splitted at the activity 1 and moved to Q2. Change over time is used to reflect things which happen in between an activity processing work items, such as essential maintenance, refueling, cleaning, or any other activities. What is the default setting? By default, there's no change over time associated with an activity. It is our choice whether or not to consider this feature. To access the change over settings for an activity, first select the activity, and then we choose routing in from the ribbon. We can see the tab called changeover. Right here, we can set up the changeover to occur after an activity processes a certain number of items. We also can set up the changeover to occur when a label change. Alternatively, we can also set up the changeover to occur after a certain amount of time. So in this example, let's consider there is a 15-minute change after every fifth work items is processed. Okay. Now let's run the simulation model. So we can see in 1 day time, the whole system can process around 36 work items for 1 day when the changeover is in place. Now let's consider what happened If no change over at all, we can reverse the setting for activity 1, go to routine in, and basically we just specify no setup time or no change over time. And let's rerun the model. As expected, we can process more items when there's no setup time or change over time with 41 items for one day. Probability profiles allows you to incorporate different product mix into your label values. We will start by expanding the example used in the label tutorials and routing out tutorial, where we use the label called LBL-color to differentiate blue and green work items. We are going to expand the example. Instead of saying that we are equally likely to have blue and green work items, we are going to change our simulation model so that we will have 30% of cars are blue and 70% of them are green. The first step is to create a new distribution. Go to Data and Rules tab and choose Distribution. We click New and let's call it this color and choose Probability Profile. So on the new screen, we see that we have 10 columns, but we only need 2 of them. So let's delete the unnecessary column by right-click on the column and choose Delete. All right, now we have 2 columns left. Make sure that we have the correct percentage for value 1 and 2. In particular, we should have 30% for blue car with value 1 and 70% for green cards with value of 2. It is important to check this because we are going to link the label to this distribution later. So now we already created a new distribution called this color. A probability profile can be attached to the simulation model using a label. So please see the relevant video in the pop-up link or use the link in the video description to see how to create a label or use the label to routing out to different work items. Next, we choose label and we choose add action to the label at the activity work item by choosing set to. And right here, we should choose the new probability profile distribution we have just created called this color. All right. Now we have created and also attached a probability profile to the label within our simulation model. We are ready to run the simulation. All right here we see the percentage of blue is around 30% and the percentage of green car is around 70%. So please remember, randomness is incorporated within the probability profile. So we want to get exact 30%, 70% split. This is a percentage chance of a value being assigned. Visual logic is simulation language. It let we build detailed logic into our simulation to describe exactly how we want it to behave. And this example explains how to build visual logic code. It will give detailed instruction about how to input and edit visual logic. The example is a process where a standard facility is supplemented by a backup facility at busy times. First, let's create a simple simulation like this one on the screen right now. And then we can copy the activity 2 and its queues by dragging a box around the queue and the activity, and then drag the box while holding down the control key on the keyboard, like this one. All right. We are going to send the work item to activity 4 from activity 1 when there is not much work waiting at the important activity number 3. But only if activity 2 is getting behind with its work. There is a queue for sure of work at it. Specifically, if there are less than or equal to 3 items waiting for activity 3, and there's a queue at the activity 2, then we will send the work from the activity 1 to the activity 4 instead of activity 2. And to do that, go to the Data and Rules tab. Open the label ribbon. We can add a new label. Let's call route to take. And then we add activity 1 as an object to this label. And choose route out by label. Now we have to add the visual logic code to set the label to either 1. Go to the first destination in the list, which is Q2, or 2. Go to the second destination in the list, which is Q4. Now we click More. On Work Complete button, we will see a new dialog shows up. And we have a blank window where we can enter the visual logic. This visual logic will be obeyed whenever a work item finishes its work at the activity number 1. As the window says, so click the right mouse button in the window to start adding visual logic. The first thing to do is set the label to default value. We can do this by choosing Set. The Set Value dialog appears. We can click 3 dots in Information dialog. The formula editor appears. Select the label checkbox. And we want to set the route to text, so double click it and then click OK. Now we type 1 as default value for the label route to text. And then we click OK. So right here, we already set the default value for the label route to text equals to 1, which means the word from activity 1 will go to Q2 for activity 2. Now click the right mouse button again in the Visual Logic Code window and add an if line. So we see the conditional block editor dialogs appear. And we will want a line that looks like this one. If Q3 count contents is smaller than 3. And to do this, we click the 3 dots and use the formula editor to choose the object checkbox and choose Q3 with count contents. Click OK. The type of condition is less than or equal to. And the value we should put in is a 3. All right, next, we will add another if line inside the block for the first if. And then add another set. So we will have some codes like this one. If Q2 count contents larger than 3, then set the root to text equals to 2. We can drag it again and choose if. Okay, we can use the 3 dot to specify the object we want to set is the Q4 activity 2, which is Q2, and the count content. The type of condition now is larger than. And the value now is 3. To finish this if line, we need to have a line set label root to text equal to 2. So now we already finished the visual logical. It is time to run our simulation. And as you expected, running this simulation will increase the utilization of activity 3. Now we can check the utilization of activity 3 with the activity number 4 and its queues. First, we can notice that by the end of the week, the facility has processed 213 work items. And now we can check the utilization of the activity 3. We see that the weighting is around 11%, and the working performance is around 89%. This is good. Now we can check what is the utilization of activity 3 without activity 4 in its queue. We can delete this one and rerun the simulation. By the end of the week, the facility can process 210 items. Now let's check the utilization of activity 3. The waiting time is larger. It's around larger than 12%. And the working time is smaller. It's around 87%. The graphic image of a work item can be based upon a label. We are going to use the same example that we used in the video call using label to root out, where we sorted blue cards and green cards. So please check the relevant video in the pop-up link or use the video in the description for your preference. Now we go a step further, we will turn the default image, the red bone, into the blue car and green car. So let's run this one with slow speed. You can see the default image is the red bone. We want the image after left the activity 1, we will see blue car go to blue queue and green car go into green queue. And the color of those images will depend on the value that we assign to the label LBL-color we created previously. We can check the label we already created. So right here we can see we have the label called LBL-color with 2 values, 1 for blue and 2 for green. Okay. Now we need to create a label-based distribution. We can go to Distribution ribbon under Data and Rules tab. Click New, choose Label-based, Next, and we should choose the label that we already created, which is LBL color. Click OK right here. Okay, that is the first step. Next, we need to prepare the relevant image used for blue car and green car. To do that, click on Activity 1, go to Graphics, and click Work Item on Assets. Manage Image for these simulations. Work Item Image on Assets. We can create a new image. Okay, so we can open the library and choose the image that represents for blue car. Okay, and let's call it car 1. Okay, we can do the same thing for green car. Let's call it car 2 and choose a relevant image from the library. All right. So now we are going to create a second label. This label is important, and this must begin with image with colon punctuation mark. This is a necessary instruction to simulate, so it can understand that we will use this label to search for image in the library. We go to Data and Rules, open Label ribbons, add a new label, and let's call it Image. And in this case, it is car. This label means that it will look up the image library for image called car. It then selects the image that ends with the value source from the label color, which is either 1 or 2, and will return the blue car image or the green car image. And to do that, we can add the object to the new label, which is activity 1, and we can add action to this label. In particular, we would like to set this label to the label-based distribution that we created previously, which is LBL color. Click OK. Now, let's rerun the new simulation. So now we already see the blue car image appear after the work item left the activity 1 and go to the blue queue, and the same for the green car image, go to the green queue. This is what we wanted.